Hello everyone, in this video we will be solving problem 1653, minimum deletions to make a string balanced. The problem statement is, you are given a string S consisting of only A and B characters. We can delete any number of characters in the string S to make it balanced. When we say balance, the problem statement is asking us to make sure that all of the characters to the left hand side of a particular partition will be A and the right hand side should be B. If you look at example number 1, it contains several characters of A and B. To make this a balanced string, we will have to remove two characters. If you look at the first one, we can remove two characters or two B's from it at index 2 and then index 7 to make it a balanced string, something like this, where we have 3 A's and 3 B's, or we could remove 2 A's from the second half of the string to make it 2 A's and 4 B's. Now let's dive into our notepad and understand how we can solve this problem. Let's use the example that we have been given in the problem statement. If we were to solve this problem using the basic approach or the brute force approach, we would start by placing a partition at every index and then look for all the characters to the left hand side and to the right hand side, and if there are any B's in the left hand side, we will delete them, or if there are any A's on the right hand side, those will be deleted as well. Calculate the number of characters that we are deleting on B's and A's on both the sides, add them together and then save it to a variable. As you may have imagined, with this approach, our time complexity will be O of n square, because at every partition we need to run a loop towards the left hand side and towards the right hand side to calculate the number of A's and B's. Now let's think about how we can use this as our basis to come up with an optimized solution. As we are solving the problem for first index and then moving on to the next one, or placing the partition at the next index, the solution that we have calculated for the previous one can be reused. And then as we move forward, we can just continue to reuse the same previous solution and then build on top of that. We'll use this approach to come up with an optimized solution. We'll use this table to record where we are placing the index, which is I, the left hand side, the number of characters we are replacing, the characters replaced on the right hand side of the partition, and the total number, so L plus R. Let's start with placing the partition at index 0. As there are no characters to the left hand side of the partition, my L counter will be 0. And on the right hand side, we need to calculate the number of A's, because we expect everything should be B if we want to build a balanced string. So in this case, we have total of 4 characters or 4 A's. So my total is 4, which is currently the minimum number of characters. So I will save it in this return variable. As we discussed earlier, we want to reuse what we calculated in the previous state. So when my partition is at 1, I went past the character A. Now that A is part of the left hand side, which is expected, we don't need to do any deletion on the left hand side. So my L counter will still be 0. But when it was on the right hand side in the previous calculation, we had to remove it. But now that it is moved, the counter for R needs to be decremented by 1. So the new value will be 3. Adding 0 plus 3, the total is 3, which is better than current saved value. So we will update it. Index 2. So in the new partition, we went past another A. So my L counter will be 0. R counter will be decremented by 1. My total is 2, which is better than the previous recorded value. Let's go to the next one. 3. Now we went past the character B. So B is on the left hand side now, which needs to be deleted because we want all A's on the left hand side of the partition. So my L counter will be incremented. So it will be 1. But this B was moved from the right hand side and it was not being deleted anyways. So no changes to the R counter. So it will still stay at 2. 1 plus 2, my total is 3. It's not better than what we recorded earlier, so no changes to my return value. Similarly, we'll continue the approach incrementing our I index, placing the partition at every position, and then see what is the best possible combination we can build, and then accordingly update the return value and return it at the end. Using this new approach, our time complexity has been improved from O of n square to O of n, and our space complexity is O of 1. Let me show you how we can implement this using C#. Here is my solution in C#. In the primary method, I start by adding the check to make sure that the length of the input string is greater than 2. If it is not, then simply returning 0 would suffice, because if the character length is 0 or 1, there is nothing to delete as it is already balanced. Post that, I have a couple of counters to record the number of A's and B's in the string based on the partition where we place. The first for loop is to identify the number of A characters on the right hand side when the partition is placed on index 0. So I'm only checking if the character is A, and if yes, then I'm incrementing the B counter, which means the number of characters that needs to be replaced on the right hand side. After the loop is complete, whatever is the value in the B counter is set to the return value, because that's the maximum number of characters that needs to be deleted. Then I start with another for loop to check all the characters and then accordingly manipulate the counters. If the character is A, which is to be moved to the left hand side, it's no longer part of the RHS, so it doesn't need to be deleted. So I decrement my B counter. If the character is a B, or we go into the else condition, so now a B is being moved to the LHS based on the partition that we are placing. In that case, we need to delete it on the left hand side to make it balanced. So I'm incrementing my A counter. After the check, we add the A and B counters and then compare it against the previously recorded return value. And whichever is the minimum, we save that. After the entire for loop is complete, we will have the minimum number of characters that needs to be deleted in this return value variable. I hope you were able to understand this explanation and this code. The link to access this code is available in the description. Feel free to check that out. Thank you for watching this video, and I will see you in the next one.